Today I'm going to show you how to rotate 3D objects both around axes when they are off axis and around lines parallel to the main axes. I have an example set up here of a cone which I have created and moved 2 units along the positive x-axis. I moved it here out of its original centered position so that I can better show you the effects of rotating it around axes that it is not in contact with. Notice the simple code here on the left where I create the cone, my cone, color it wood colored, move it over 2 units, and then display it using the show command. First, let me show you what a rotation on an axis that the object is touching looks like. The cone is touching the x-axis here. So I will give you an example of a rotation around the x-axis. I'll just add in the line of code here, rotate, my cone, as in the object to be rotated, 30 is in the number of degrees to rotate it, and then a capital X, meaning rotate around the x-axis. Remember the right-hand rule, and imagine grabbing the x-axis here with your thumb pointing out with the arrow. The number is positive, so the rotation should be going in the direction of your fingers, wrapping around in the counterclockwise direction. Let's run our program. As you can see, our cone rotated in the counterclockwise direction around this x-axis. Since our cone was resting on this axis, it rotated in place around it. Let's reset our cone to no rotation by putting a 0 in the degree measure and running our program. It is now back in its starting position. Let me show you what a 30-degree rotation looks like around the y-axis by changing the second parameter to 30 and then the third parameter to a capital Y. Once again, remember the right-hand rule, and that a positive number of degrees in the rotation will lead to a counterclockwise rotation around this y-axis, the green arrow. Let's run our program. Whoa, that looks very different from our x-axis rotation. Our whole cone has moved this time, instead of just spinning around an axis and remaining stationary. Because our cone isn't resting on this green y-axis, it orbits the whole object around. Even though the number of degrees in these rotations was the same, the different distances of the objects from these axes made the rotations completely different. Let me show you what a 90-degree rotation would be like for this cone around the y-axis. Once again, the cone was completely displaced 90 degrees. Let me show you a 180-degree rotation. As you can see, both of these created large movements for the entire cone object. Now let me reset this cone to its original position. Now what I want to show you is how to rotate objects around lines parallel to the main axes using the rotate command. So let's make our cone rotate in the same location like we did earlier around the x-axis, except let's do it with a line that we create that's parallel to the y-axis. We do this by adding a 4th parameter to rotate. This parameter is a point through which our new axis of rotation is created. The rotate command makes an axis parallel to the axis given in the 3rd parameter, which passes through the point given in the 4th parameter. Let's make this point 2, 0, 0. That point is located at the very center of the bottom of our cone. And it will create an axis here parallel to y, which goes through this point along the xy plane. So let's do that and add a 30-degree rotation and run our program. The object stayed in the same location, and you see this axis here, which we defined as an axis of rotation using this point and this axis, was the point around which the cone rotated. So let's do one last example where we create an axis. Let's change the point in the rotate command to 2, 0, 2, which will be the tip of the cone when the cone is in its original position. But first, let's set the degrees to 0, just to put it back in its original position. Now let's change that point to 2, 0, 2, which is once again at the apex, or the tip of this cone here. And let's give it a 45-degree rotation. And our parallel axis, the third parameter, is still y, represented by this green arrow. And the new point is at the very tip of the cone. So our new axis of rotation is a line which is parallel to y, moving in this direction, but which also passes right through this tip. We know by the right-hand rule that our positive degree measure should cause a counterclockwise rotation around this axis. That means it should be going in this direction. Let's run our program and see the results. The cone is now rotated 45 degrees around an axis parallel to the y-axis going through its tip, which we defined. As you can see, the ability to rotate objects around parallel axes is very powerful. Remember that though in this lesson we've only rotated around the x and y axes, it's also possible to rotate around the z-axis, or on any axis parallel to it. When rotating around the z-axis, it's very similar to performing two-dimensional rotations. So to sum this lesson up, remember a few things. First off, when objects rotate around an axis they are touching, they will rotate and not move from their position. Secondly, remember that when objects are rotated around an axis that they are not touching, they will orbit the axis and move a lot. Third, remember that to specify an axis for an object to be rotated around, you will put the letter representing that axis in all caps as the third parameter of the rotate command. And then lastly, remember that to specify an axis of rotation for the rotate command, we need to add a fourth parameter, which will be added with a point on that axis. And then the rotate command will construct a rotational axis parallel to the one specified by the third parameter, but which also passes through the point defined in the fourth parameter. Play around with 3D rotations. They can be hard to understand at first, but they're very powerful once you do understand them.